Hello, dear student. Today we're going to dive into the fascinating world of physics and discover one of the most important laws that govern the behavior of materials, which is Hooke's law. Have you ever wondered how the spring can stretch and return to its original shape? Or how materials can withstand external forces without changing? The answer lies in Hooke's law, which describes the relationship between the force applied to an object and the resulting deformation. During this lesson, we will conduct a practical experiment to measure this relationship and discover how Hooke's law can be applied in our daily lives. I am Nourhan Mohamed. I am physics teacher at Fusul Online. In this session, we will see Hooke and understand what will happen in the spring. Hello, Hooke. Hooke, he used the spring to see me. What is the relation already between the force and displacement? Can you think what is the relation? What will happen if we increase the forces, increase the weight? What will happen to the displacement? Or this increase or decrease? Okay. At first, this is the spring. He go up, down, and now we will see the weight. Okay. Now, this spring doesn't have any weight, no extension, no move. Then, we will have one weight, small extension, two weight, more extension. It's already when we increase our weights, we increase the extension. You can see it like this. At first, he started from zero Newton and zero displacement. Then the force is increased, more increased to become 40, 60, 70, 100. And the displacement here is started from zero to become 0.5. When we increase already the force, we increase the displacement. What will happen if I go back? Now I have a two direction. One of them is go down and another is go up. If you make a stretch already, Hooke, it will use the positive sign. But if you go to make a compression or go back, Hooke will use the negative sign. We will see it in the Hooke's law already. But at first, we should understand the relation. Hooke's law already for relatively small deformations of an object, the displacement or size of the deformation is directly proportional to the deforming force or load. We already said that when we increase the forces, we have a direct proportional to increase the displacement. Start from zero and stretch it to become S1, then Y is more displacement because more weight. Do you know what is the formula? Okay. At the Hooke law, he speaks about the force and the displacement. It's mean we have force F and the displacement X. Between them is directly proportional. It's mean direct. Okay. Hooke, he used this formula to make the law. F is equal. When you replace the directly proportional, you should make a constant. The constant here, it will be K. The spring constant times X, the displacement. Then he put a negative sign. Do you think why he put a negative sign? Yes, we remember, because he knows there is a two direction. You can make a stretch to go down or compress to go up. For that, he used a negative sign. Okay. This is the spring. The formula F is equal negative Kx. F is the force applied. K is the force constant. X is amount of deformations or the displacement the spring already made. We can see the simple problem to think with me. What is the force required to stretch a spring whose constant value is 100 Newton per meter by amount of a 0.50 meter? At first, he asked about the force. He need F. Then, what I have? Yes, I have the constant value. It's K, 100. Then, I have the displacement he makes, 0.5. Okay, I don't have F. He asked about that. I have K, 100. I have X, 0.5. Then the formula f is equal negative kx. But in this example, I should use negative or positive. Wait. I see it's stretch. Stretch, it means go down. It means positive. Exactly. Because he already go down. Everything when I make fall down, he go down. I will replace k with 100. Replace x with 0.5. F is equal 100 times 0.5. It's equal 50 Newton. You can try in this question. A force of 100 Newton is stretching a spring by 0.2 meter. Calculate the force constant. You know the formula F is equal kx or F is equal negative kx. He said stretching. Then you have the force and have the displacement. You can get the force constant. Okay. If you know the answer, write it in the comments. And if you wanted to enjoy studying with us, subscribe to our online platform, فصول online, through the pages message. Goodbye.